Alright, this is Austin Eldridge. Today we're going to look at some C++ code I wrote for a basic neural network in a creature simulation environment. The point of this program is, first of all, to practice C++, but also to understand better neural networks and understand better evolution. So this program does is it creates entities specified by the user, and it takes this entity and it places it into a grid, a 100 by 100 grid, and it gives it random traits and random output traits and a random color. And when we run this, as you can see, just for an example, the intent is that we will be able to create an entity that can evolve to survive in its environment in the best way. So right now, um, the current environment, the way that they need to survive is to move to a certain location. In the future, I'd love to update it to add food or something like that. For now, we'll just do 20 entities. Generations, we'll do 100 generations, and then we'll do 100 steps per generation. So a step inside of a generation is simply at the beginning of each generation, all the entities that are there that have reproduced or new entities up to the specified user number are created, and they're placed on random locations on this grid. And the random locations on this grid will decide whether they live or die in the very beginning. But after that, their input traits should either move them to the specified location or they'll die at the end of the round. And the steps are just how many times they can move in each generation. So, scenario 3 is what we're going to use. And you can see this is generation 10. These are the random locations given at the beginning of the generation. But it lets you see the graphics, and soon I'll be able to update it to where we can see every generation. But if we look at the generation's 10 ID, you can see that there's a specific trait combo here that is surviving much more than the others, and that's 81. Um, 81 makes sense to survive more than the others. I believe environment 3 is the top of the surviving zone is the top 20 spots on this grid. And this is the beginning of the generation when they haven't moved yet. But if we take a look, the traits were 81, correct? Let me move this up. The dominant trait is 81, and so we are going to take a look at these input and output traits, if this will close. Thank you. Input and output traits are very simple right now, and they're meant to be simple just so that they can become more complex with more of them. So 81 is simply the output trait is move upwards, and then the if statement, or the input trait, is if it's surrounded by creatures. This is probably not perfect, but it's close. These traits will reproduce quite significantly, and they reproduce at their own amount of traits squared for each round. So sometimes you'll get these random traits that maybe don't make the most sense. They're not the perfect ones, but they're still good. As you can see here, it looks like we have a lot of the similar colors. Let's look at the generation number. So this one, 81 is starting to dwindle off, and 44 is starting to become the dominant trait. So the input trait for 4 is creatures directly below, and the output trait is moving right, which is unique. Anyway, if we run this generation, I think we put 100 generations or something like that. We can see we have some dominant traits. We have some that are still crazy. I think a lot of this has to do with some bugs in the program, but for the most part, you can see that traits are reproducing and becoming dominant. Um, so that's my neural network for now. There's work that needs to be done. I'd love to integrate this into Unreal Engine and show it as like an actual simulation where you can see the creatures move in real time, and you can see them fight for food or anything like that, and reproduce on their own. Um, yeah, so still some bugs that need to be worked out, but besides that, it's been a ton of fun to work on this project. It's pretty malleable. It's super efficient in its own way. All the entities use a map instead of a list, so there's no iterations through that list. There's iterations through the numbers of entities multiple times throughout the program. But if you need to check an entity next to another entity, you don't have to check through all of them. You just got to go through this map. I'd love to add a map, another map with the same entity locations using the location, so that we don't have to check each. We don't have to iterate to find which entity is near another entity. But for now, this will work. Thank you.